Okay, so we have this binomial and multinomial theorem. This thing, I don't think for the first time, it's 2022 batch, they won't be asking what to say, uh, this theorem. Okay, so just see this theorem, how they have proved. Okay, so they have derived this two things over here. Okay, so they have said that see here, a basic property of C of n comma r is that it is a coefficient of x to the power of n minus r into y to the power of r in the expansion of the expression x plus y to the power of n, where x and y are any two real numbers. In other words, the expansion of x plus y, just a second, x plus y to the power of n in powers of x and y is as follows. See, x plus y to the power of n can be written as x power n plus nc1 into x power n minus 1 into y, then nc2 into x power n minus 2 into y power 2, ncn minus 1, like that. Okay, just remember this. See here, see this, and remember they will ask for so only not x plus y, sometimes it will be x plus y plus z also. So these are the expressions. Okay, multinomial theorem in which more than x plus y, so x plus more than two terms are there, x plus y plus z, a b c d e f g, like that. No, okay, we don't want that. We'll start with problems. Prove the following entities for a positive integer. If n0 plus n1 plus so on up to nn is equals to 2n. So given x plus y to the power of n, okay, the polynomial theorem for a positive integer index n is given by x plus y to the power of n summation r is equals to 0 to n nr into x power r into y power n minus r. Here we are taking x as 1 and y as 1. See, 2 power n can be written as 1 plus 1 to the power of n. Okay, in x plus 1, in y plus 1 we have, and what to say here, and see here we get 2 power n is equals to summation of r equals to 0 to n nr 1 into r into 1 to the power of n minus. We are just substituting the value of x and y, that's it. Now what we'll do, 1 power anything is 1, this power anything is 1, so this thing will go off, remaining is only this much, that is 2 power n is equals to, again what we had to prove here, 2 power n is equals to this thing, right? That's itself we got, very simple. Then taking second one, we have here like this, n0 minus n1 plus n2, here plus or minus, okay, this is minus then plus, then minus then plus, minus plus, so on up to minus 1 to the power of n into n by n is equals to 0. Okay, here we have x is, okay, so here we have to take 1, c 0 to the power of n I have, so 1 minus 1 or minus 1 plus 1. Okay, here they are taking x as minus 1, y as 1, so we get same way you have to just substitute minus 1 to the power of 1 to the power of minus r, so on like that. So remaining is only minus 1 to the power of r of, anyhow you can take any, both are fine if you have, but it's better to take for this only x place, because x will have only the power of r, right? Same way this also you can write off same way. See, so this will go off, this will go off, remaining is minus 1 to the power of r. So you have to take 0 is equals to n of 0 minus n of 1, n2, so on up to minus 1 to the power of n. So same way it proved, right? N0 to r is equals to 0 to n. So the last term, first it will be r will be 0, then 1 to so on up to n itself. Instead of r place, you have to write once you have to write 0. So minus 1 to the power of 0 is 1, 1 into n 0. If you have put 1, minus 1 to the power of 1 is minus 1. So minus of n by r. Then minus 1 to the power of 2, it is plus 1 plus 2r, like that. Simple. Okay, same way they have asked us to compute the following: 12, 5, 3, 2, 2, 8, 4, 2, 2, 0, 10, like that. Okay, first see, 12, 5, 3, 2, 2 is equals to 12 factorial. It's very simple. Whatever is given, just add factorial, divide it, and every term factorial into factorial, like that. You will get answer. Second term, 8 factorial divided by 4 factorial, 2 factorial, like that. Simple, you got. And third one, see here, 10 factorial divided by 5 into 3 factorial into 2 factorial into 2 factorial. Multi meaningless, since 5 plus 3 plus 2 plus 2 is greater than 2, or 12, which is greater than 10. Okay, so here what they are saying, third one is meaningless, because see, sum of this should be greater than equal to n. sorry, less than equal to n. I said greater. So here 5 plus 3, 5, 6, 7, 8, then 9, 10, 11, 12, which is equal to n. This also should be equal to n, but here it is going more than 10, so that is meaningless you are writing, since this numerator is greater than 12. If you take this sum, first condition is, I skipped the definition in the beginning, right? So what they are saying, condition is denominator, this number should be equal to this numbers. Okay, that's it. Find the sum of all coefficients. See, this one is okay, a good interesting sum. Okay, so all question in the expansion of x plus y to the power of n. We have x plus y to the power of n is equals to summation of r is equals to 0 to n, n r, x power r, y power n minus r. Taking x is equals to 1, y is equals to 1, we get 2 power n is equals to, same, we had solved first question, that is 2 power n is equals to n0 plus n1, so on up to n by n. Okay. If you take 2 power n, x has 1 and y has 1, this both will go off, because 1 for anything is again 1, 1 for anything 1. So remaining is only, this will remain. That's why summation of 0 to r n by r. So only in r plus we will write 1 times 0 plus, then again summation is addition, right? So on 1 times 0, 1 times 1, 1 times 2, so on up to n. Thus the sum of all the coefficients in the expansion of x plus y to the power of n is 2 power n. Okay, then second, by mathematical theorem we have summation of ni, n, and then n1 plus f2, so on up to nk into this for the second month. Okay, and here we have x1 to the power of n, x2 to the power of n2, x3 to the power of n3, so on up to xk to the power of xk should be there, where we should be, this should be equal to x1 plus x2 plus x3 whole to the power of n. This is the formula. This formula you remember. This formula will be helpful for us in a further thing. These sums which I have solved so far has very less chances to occur in your paper. So from here which will be solving will have more. So you are taking x1 as 1, x2 as 1, and so on. All are 1. Okay, so all will get 1 plus 1 plus 1, so on up to the power of n, k times, which is equals to k to the power of n. So now see here, 1 to the power of 1 into, okay, this into 1 to the power of n1 is again 1. So here we are not writing this part. This part we are not writing. Only this will come. So there is 1 plus 1 plus so on up to 1, which is nothing but k number of times, k into the power of n, like that directly we will write. So there is thus the sum of all the coefficients, the expansion of this is k power n. Then obtain the sum of all coefficients in the expansion. First, I have x plus y to the power of 10. Okay, just a second, I'm plugging in my laptop charger. Okay, so now x plus y to the power of 10. Now I have n as, what to say, 10. Okay, now see here. From the result A, the above problem, the sum of coefficients in expansion of x plus y to the power of 10 is 2 power 10. How I am getting 2 power 10? What I'll do, see here, I have here, right, instead of n, only 10 is there. Okay, so 1 power r into 1 to the power of 10 minus r is again 1 itself. So I have r is equals to 0 to n is equals to 10, 0, then here 10, here 10 once, then here also 10, so on up to here 10 by 10, 10. So here this is nothing but 2 to the power of 10. Okay, we got off. Then x plus y plus z to the power of 12. Again from this thing I can just write off. See, from b is 3 to the power of 12. Okay, how many times these are there? 3 times it is there. So 3 power 12. Okay, k is number, nothing but number of elements there, number x, y, z. Okay, that and all. Then here x plus y plus z plus w to the power of 4. So this I can write as 4 to the power of 5. If we see here, see, simple, right? Then I have 1, 2, 3, 4, 5, 6, 7 to the power of 10. But here we have to solve it once, which is very complex sum, one of the complex sum. Just see this. I'm not solving because there's no chance that this will come. Find the coefficient of x cube y power 9 in the expansion of x plus. So these are the main questions. Okay, I'll explain only this, and then I won't be doing the remaining thing. Okay, x cube into y to the power of 9 in expansion of x plus 2y the whole to the power of 12. Now x plus 2y to the power of 12, n is 12, x plus I have x is y plus I have 2y. Okay, then I have r1 as 3, so okay, just leave that. N1 as 3 and N2 as 9, that is. Okay, then summation of r is equal to 0 to 12. 12 r x power r into 2y to the power of 12 minus r. Now what I will do? Okay, x into r, 2y into 12 power minus r. Now I am considering, so what I will do? 2 into 2 to the power of 12, see 2y to the power of 12 minus r can written as 2 into 12 minus r into y into 12 minus r. Okay, so what I am doing, I am grouping xy separately and this I am writing first. Okay, so I got here x power something. Now I have to take the value of r in such a way that it will satisfy this place, 3 and 9. So I'll take r as, let us take r as 3. So I'll get taking r as 3, x power 3 into y power 12 minus 3 is nothing but 9. So the coefficient of this term is 12, 2 power 9. Okay, here I'll have 2 power 9. Okay, 3 to 12, r is equals to 0, r is equals to 3 to 12, 12 here 3, just write off 2 to the power of 9, which is nothing but 12, 3 to the power of 9, right? 12 factorial divided by 3 factorial. 3 to, okay, here 3 is going, so 3 to 9. So this thing, see, instead of writing this, you can simply take, so you have 12, here you have 3, here you have 2 to the power of 9. So this is nothing but n, this is r, n factorial divided by n minus r factorial into r factorial. Okay, 6 factorial divided by 3, see, understood, right? N factorial, this is n factorial, n minus r factorial into this factorial. We can simply take this as 12c3. Okay, let me just take that in my calculator. 12c3, that is 220 into 2 to the power of 9. If I take, I am getting 11264. Okay, just remember whatever you have here, that is nothing but 12c3 into 2 to the power of 9. That's it, by binomial theorem. Okay, second one. Okay, now see here, x power 0 in the expansion of 3x square minus 2x 2 by x to the power 15. Instead of x I have 3x square, instead of y I have 2 by x, and n plus is 15. Okay, by binomial theorem, 3x square minus 2x over 15 is equals to r is equals to 0 to 15. Instead of x I'll write this plus, instead of that I'll write this term minus, it is okay, minus I'll write. Okay, same I'll write. Then what I'll do, I'll open it up. So I'll what I'll do, I'll take so 2 is there, right? The 2 I'll keep as it is inside. Here 3 is there, 3 to the power of r into x to the power of 2r. So what I'll do, 3 to the power of I'll keep here. I'll take x to the power of r here. Then here minus 2 to the power of 15 by r I'll keep this here. I'll take 1 by x to the power here, like this. Now you can see here in the given question it was x to the power of 0, right? X to the power of 0. So for y nothing is there. So y is nothing but 1. Y is nothing but 1. X to the power of into 1 gives me x to the power of 0 itself. So y value is 1. Simply I can assume that y is 1 here. Okay, now see here, where it is. Now here, if I have this, now I'll multiply this. Okay, x to the power of 2r into 1 by x to the power of 15 minus r is there. If I take this in the numerator, 1 by 1 to the power of 15 by r divided by x to the power of 15 minus r. If I take up, signs will change. So minus 15 plus r will become, so r minus 15. X to the power of 2r into x power r minus 15. Bases are same. I'll just add. So r minus 15 plus 2r. So it will be 3r minus 15. You understood how I got 3r minus 15. Then I have this coefficient. So I have to take the value of r in such a way that I will get 0. So 3 5s are 15. So I'll take r as 5. So 15 minus 15 is 0. I'll substitute r place here 15. 3 to the power of 15 into, like the same. I'll calculate. I'll get 15 here. Sorry, I not take 15. It should come 5, right? R is 5 I'm taking. So 15 C5 into 3 power of 5 into minus 2 to the power of 10 I'll get one value. That is my coefficient for this. Find the this its coefficient in expansion of this. Okay. Same way you see here. I have from binomial the formula, right? Just see. I won't explain. I know it is blurry. Even it's okay. Now I have three terms. Another expansion was there, right? Here so far only x and y was there, but here I'll be using that kth term was there. So x y z to the power of 5 in the expansion of x plus y plus z to the power of 7. I'll just show here in this separately. I'll explain that model paper also. In that you will understand how I'm solving this. Okay. By multinomial theorem we have that in the general term. Okay. Okay. See here x plus y plus z to the power of 7. I have to write the first formula first, the way of writing. Then I'll write this is my what to say n. Okay. This is x1. This is x2. This is x3. Okay. Now see here. I have here x1 to the power of 1, y1 to the power of 1 and z to the power of 5. So n1 is 1, n2 is 1, n3 is 5. Okay. So I can write this in the form of 7, n is 7 by n1, n2, n3, x to the power of n1, y to the power of n2, z to the power of n3. So here I have 1 here. Here I have 1. Here also I have 5. So I can write here 1, 1, 5, x into y into z to the power of 5. So this can be written as 7 factorial divided by 1 factorial into 5 factorial into x, y, z factorial. Okay. Then which is equals to 42. This is 42 x, y, z. So the coefficient of this is 42. That's it. Simple. So second question. So in general term, the expansion of So the second term, x square, y square, z cube, as in terms of this. Now see here, this is my x1, this is my x2, this is my x3, this is my n, this is my n1, n2, n3. See in the question I have given you all the whatever is required. Now you can see here, I can write it in this form now. Second one, right? So again I had 7 n1 n2 n3 into x1 to the power of n1 x2 whatever I have written 2 n2 3. Now whatever is given, that power 2 2 3 was there. So I'll write 2 2 3. Here I wrote here x into y into z to the power. Why? Because in place of x I had x, in place of y I had y, in place of z I have z. But here I am writing 3x minus 2y minus 4 because in place of x I have this, in place of y I have this, in place of z I have this. Like that. Then I'll just multiply it. 3x square is nothing but 9x square. 9 into x square minus 2y the whole is nothing but plus 4 into y square. Then minus 4 for the 16 like that. 16 like that. See minus 4 cube x square y square z cube I got of. Then I have to just solve this. It is nothing but 7 factorial divided by 2 factorial into 2 factorial into 3 factorial into 3 square into minus 2 square into minus 6 square. So I'll get this value. Why I am getting minus? Because I have minus 4 cube, right? So this thing will give me minus value. Minus into whole thing will become minus. Now see here, I'll show you here also. Now I have x, y in terms of 3 here they have given. Z is not there. So it's nothing but z is as 1. Or you can consider z to the power of 0. So n3 is nothing but 0. Okay. N 7 x1 x2 x3 n1 n2 n3 solve it. Same way n1 is 1 n2 is 2 n3 is minus 2. This is x1, this is x2, this is x3, this is n. Okay, here I have see n1 n2 n3 n4 x1 x2 x3 x4 this plus 5 I won't consider. Okay, this thing I'll show. And here n is 16. Okay, let me go to that sum one place. Yeah, now see here this thing x1 x2 x3 x4 and 5 to the power of n power 5. So here what I will do, I will just consider extra term a b c d, that e like that. Okay, instead of here I don't have e. Okay, now see here I have to write it in such a way that, so in the given question I had only, did they write here? They did not write here. I have to go again here. See a square b cube c power d power 5 2 3 2 5, right? See 2 3 2 5 is there. If you add this and total it is 16. So 16 minus this will give me this is 12. So 5 plus 3 is 8, 8 plus 2 10, 10 plus 2 is 12. and then 16 is there. So remaining this term, the power is not given, right? So I can simply consider as extra term, that is suppose any x5 as this itself. This is my x5. The power is not given, so I can remove from total power. So it should be n should be 16. So I have n1, n2, n3, n4. So n5 is equals to 16 minus n1 plus n2 plus n3 plus n4. I got like that. Now you got all the values, right? So see here, they want us in the form of this coefficient. So this term I won't remove out and write separately. This term I'll include inside here. Here you can see this, right? Then I have to put 16 factorial into 2 factorial, 3 factorial into 2 factorial, 5 factorial, 4 factorial into 2 cube into minus 3. So this thing is here. At the end, you will get this value. Note that I think here it might go minus, or because I have here into minus 3. Okay, minus 3 square will become plus itself. Okay, that's it, done. Then again I have few homework questions. If you do it, if you are not able to solve, just let me know. I can do it. So here this is last part, I guess. Combinations with repetitions. Okay, now let us see. Combinations repetitions. Suppose we have to select a combination of R objects with repetitions from a set of n distinct objects where okay, the number of such selections is given by C of n plus R minus 1, n plus R minus 1 comma R. So we had C comma R, right? So we are taking C plus, sorry, C of n comma R. Let me just erase it. I had C of n comma R. So I'm taking n plus R minus 1 minus R, which is equals to same wherever it was, n was there. I'll just add R minus 1, n plus R minus 1 factorial divided by n minus 1 factorial divided into R factorial. There in the compare the previous that was n factorial divided by n minus R factorial into R factorial. Here inside this R has become 1, and here it has become plus R minus 1. Why did I write plus, man? Okay, okay, that's it. Now we know got the formula. You have to remember formula. Once write the formula in a sheet and then remember, but because you have to remember. Okay, now okay, which is equals to C of R plus 1 n minus R comma n minus 1. So instead of R, I can simply write it as n minus 1. Okay. Now that is C of n plus R minus 1 comma R is equal to C of R plus 1 R plus n minus 1 comma n minus 1. So this is one equation. It represents the number of combination of n distinct objects taken R at a time with repetitions allowed. Okay. Now we will go for first question. In how many ways can we distribute 10 identical marbles among 6 distinct containers? Marbles are 10, all are same, but 6 containers are there and each container is distinct. So here, now see here, 10 identical marbles, R is repeated, so identical, so which is repeating 10, that is my R. Distinct number is 10, 6, and n is nothing but 6. So required number is equal to C of 6 plus 10 minus 1 comma 10, n plus R minus 1 comma 10, which is equal to C of 15 comma 10. C of 15 comma 10 is what? 15 factorial, 15 C10. Okay, if you just do 15 C10, 1, 5, shift, division, and then 10, you will get 3003 in the calculator. Okay, 15, just put in the C10. Okay, find the number of ways of placing 8 identical balls. R is 8 in 5 numbered box. N is 5. 5 number, say the number of box is not 5. Okay, there are 5 boxes which are numbered some number. It can be any number. It can be 0 to so on up to n. So required number is 5 plus 8 minus 1 minus 8. Understood? Very simple, right? So 12 comma 8. C of 12 comma 8 nothing but 12 C10. Get sorry 12 C8. Get the answer. Same as here. Bag contains of 7 different denominations. What is that? Denominations with at least 1 dozen coins in each denominations. In how many ways we can select a dozen of coins from the back? See, 7 different coins, n is 7. They have given dozen, so dozen is not 12. R is my 12. Okay. In number of ways, making a selection of dozen coins from a bag is C of 7 plus 12 minus 1 comma 12, that is 18 comma 12, 18 C 12. You see here, if you have any draw, I'll show this. You can see this question number, right? If you have any problem, just see this thing, very simple, right? See, if you have any problem, let me know. Write down the comment down topic name. This question number 5. All are very simple. Sixth one it is. Sixth one is kind of easy. Number of distinct items in its expansion of first. This is there. I have to remove this using that previous thing solving that. So then I'll get some value. Okay, x1, x2, x3, x4, x5, so on, x1, x2, x3, so on. Okay, where each ni is a non-negative integer and the sum of ni's is 16. Number of distinct terms in the expansion is equal to the number of non-negative integers solution of the equation n1 plus n2 plus n3 plus n4 plus n5 is equals to 16. Okay, the required number is C of 5 plus 16 minus 1 comma 16. How 5? See, number of things are 5 here, and here this thing 16 they have given here. Okay, so 16 number of distinct terms is equal to the number of non-negative solution, that is n1 plus n2 plus n3 plus n4 plus n5 is equals to 16. Okay, so basically I'll have, this is my R, it will become R, and this is how many times this is there, 1 2 3 4 5, that is my n. Here n is 5, R is 16. I just substitute the formula and get it. Find the number of non-negative integer solution of the inequality x1 plus x2 plus so on up to x6. So how many? 6, n is 6, which is less than 10. N. Okay, which gives us x1 plus x2 plus x3 is x plus x6 is equals to 9 minus x7. Okay, how we got this is simple. Okay, this should be, this term should be less than 10. So less than 10 means what? 9 minus x7. So if you are considering from 0 to 10, so this minus x7, x8, x9. Okay, like that they are taking. So how, example 2 plus 3 is less than 10, that is 9 minus next term, 3 next term is what? 4. So 9 minus 4. What is 9 minus 4? 5. 2 plus 3 is 5. 9 minus 4 is 5. Same way, okay, from this one definition we are taking this, we have to remember this, so that x7 is a non-negative integer, x7 is also non-negative integer, non-negative, it is non-negative. The required number is the number of non-negative solutions of the equation x1 plus x2 plus x3 plus so on up to x7 is equals to 9. What I am doing, this thing I am bringing inside. Okay, now I can simply say that 9 is my R and this is my N. Find the number of distinct terms in the expansion of yw plus x plus y plus z. I guess at the end I will have like this will be my R and my N will be 4. Okay, 4 plus 10 minus 1, that is 14. So it will be, okay, sorry, 4 plus 10 minus 1, 9. So 4 plus 9, 13 comma 10. I said right, correct, right? Then here find the non-negative inequality. See this one, 10th one. See of which question you have doubt, let me know. I'll solve that. Okay, I'm keeping it displaying one by one. Okay, this is one kind of interesting which has a, there are no restriction. Each child gets at least 1 pen. Yeah, the youngest child gets 2 pen. This I'll solve separately if you want, because see, this completes our complete actual syllabus. Okay, 19th one solution is this. Then 18th question solution. Okay, 17th question solution, only this much. Yeah, 16th question solution, this much itself. Okay, 15th question and its solution. Theory type it is, na, just try to get it in such a way. Okay, it's not that difficult. Here only value of n will be changing. Now see here, here 7c4, here 9c7 and case 2. Okay, then case 3 again 7 comma 5, here 4 7 comma 4. It depends on this given conditions. Okay, that's it, nothing else is there. Here also n and r value changes because of these things. Since r is changing, the n value depends on r, n plus r minus 1, like that. Okay, that's it. This completes the second module. I'll try to do third module as fast as possible and upload it by tonight. You have one whole day tomorrow, so you can see something and study from that.
Can I please ask you to subscribe? That's all we want, man. Just press subscribe.